You're going to soon find out that when you do a hypothesis test, it follows the same 4 or 6 steps. But the very first step is to make sure that you write the null and the alternative hypotheses correctly. So I'm going to help you learn how to write the null and alternative hypothesis given some different scenarios. And so we're going to do this by answering 3 questions. Question A, the first thing you want to do is determine if you're dealing with a population proportion or a population mean. Um, B, we're going to then write the claim using the correct notation, and then we're going to identify the null hypothesis and the alternative hypothesis. And then the last thing that we're going to do is figure out if we have a two-tail test or a one-tail test left tail or a one-tail test right tail, because that's going to help you make your conclusion towards the end. So in this first example, we're told that a certain company claims that they hire 50% women. So this is the claim. They claim, hey, we hire 50% women. So 50% women means we're dealing with a population proportion. So for question A, this is a population proportion problem. And so the notation that you're going to use when you write your hypothesis is your hypothesis is going to contain some p-value, okay? So in question B, let's write down the claim and then determine if it is the null or the alternative hypothesis. So the notation we use for writing the null hypothesis is H sub 0, and the notation for the alternative hypothesis is H sub 1. In this particular problem, the original claim, I'm going to write it off to the side here, is that they hire 50% women. So I'm going to translate that to P equals 0.50. And this, I'm going to keep track, is the original claim that we're going to eventually do a hypothesis test on. Okay, so because this original claim contains the equal sign, it always becomes the null hypothesis. So the null hypothesis will always contain the equal sign, always, always. So here, notice I've written the null hypothesis using the correct population parameter, using the correct symbol, and then using the correct null hypothesis value. Okay, so how do we write the alternative hypothesis? The alternative hypothesis works like this. You take a look at the original claim and you ask yourself, what if this is not true? So what if P is not equal to 0.5? Then what is the alternative? So the alternative is that P is either going to be some value greater than 0.5. So that means that maybe the company does not hire 50% women, but they hire at a higher rate. Or if that's not true, then the other alternative is that perhaps they hire at a smaller rate. So instead of hiring 50% women, maybe they hire less than 50% women. And so we have, you can see here, 3 mutually exclusive statements, either P equals 0.50, or P is greater than 0.50, or P is less than 0.50. But because we have 2 possibilities down below here as alternatives, right, we need to make sure that we have mutually exclusive statements. So how do we say that P can either be greater than 0.50 or P could be less than 0.50? Well, we can simply say that if P is not equal to 0.50, then we simply write it as P not equal to 0.50. So that tells us that if it's not equal to 0.50, it could either be greater than or it could be less than. So this statement here then becomes the alternative hypothesis. So the alternative hypothesis is that P is not equal to 0.50. So here we have our null hypothesis and our alternative hypothesis written correctly using symbols. Once you have written the alternative hypothesis, so I'll highlight the alternative hypothesis. Oops, let's use yellow. You take a look at the symbol. So notice that the alternative hypothesis contains the not equal symbol. Anytime the alternative hypothesis contains the not equal symbol, this means that you have a two-tail test. And you'll learn later on that a two-tail test, when you take a look at the normal distribution for sample proportions, okay, two-tail means that our critical values are going to lie in the left tail and the right tail of your distribution.